This is the answer key to the January 26th Desmos Module 7 review questions. Spencer gets 6 paychecks every 12 weeks. How many paychecks in 50 weeks? Use a proportion. So we're comparing number of paychecks to number of weeks. So I wrote P over W. So I'm putting all the paycheck information on top and all the weeks on the bottom. So if Spencer gets 6 paychecks every 12 weeks, I wrote 6 paychecks over 12 weeks. Now, the question's asking how many in 50 weeks. So I noticed I can't turn 12 weeks into 50 weeks. So what I had to do is I found the unit rate here. So I found one paycheck on the bottom every 2 weeks. That's what that equals. When I divide top and bottom term both by 6, you get 1 over 2. One paycheck every 2 weeks. So how many in 50 weeks? So that stays on the bottom. 2 times 25 is 50. So 1 times 25 is 25 paychecks in 50 weeks. The actual distance from Piscataway, New Jersey to Boston, Massachusetts is 250 miles. On the map, the two locations are 10 inches apart. What scale was used on the map? So looking at this, the scale, we would write, we know that the first number refers to the map's distance and the second number refers to the actual distance. So I would write 10 inches over 250 miles because it says on the map it's 10 inches. So I'd write the map is 10 inches and then the actual distance is 250 miles. Now, to figure out the scale that was used, I would divide top and bottom terms both by 10 so that the top number becomes, I know how much 1 inch represents on the map. So when you divide that, the answer is 1 inch on the map represents 25 miles in real life, in the actual distance. So the scale that was used is 1 inch equals 25 miles. The distance between Sandville and Lewiston is shown on the map. What is the actual distance between the two towns? So the first thing you should do, since they gave us, now remember the difference between this question is that they're asking you to find the scale that was used. If you notice on this map, you don't see any scale, where on this question, the scale is written on the bottom, which you typically see on a map. That's somewhere. The distance between Sandville and Lewiston is shown on the map. What's the actual distance between the two towns? The first thing I would do is I would take the scale and then we could set up our proportion. Now on the map, it's 2.5 inches. So I'm going to write 2.5 inches on top because that's the map's distance. What I'm trying to find is the actual distance. Looking at this, 1 times 2.5 is 2.5. So 20 times 2.5, I show that work on the bottom. Act like you're multiplying whole numbers, then put the decimal back in, and the answer is the actual distance is 50 miles between Sandville and Lewiston. The table shows information about the number of sweatshirts sold and the money collected at a fundraiser for school athletic problems. Complete the table and graph. So when I'm looking at this, I had to fill out the table first before I could plot. Sweatshirt sold is 4, money collected is 80. Now to be able to change 80 to 100, we can. So what I had to do is I found the unit rate. Look at the 4 sweatshirts for $80. How much did they sell for 1 sweatshirt? So I would divide 4 by 4 to get 1, 80 divided by 4 to get 20. So 1 sweatshirt cost $20. So to get 100, 20 times 5 is 100. So 1 times 5 is 5. That's how I got this question answered. Go back to 1 sweatshirt. 1 times 7 is 7. 20 times 7 is 140. 1 times 8 is 8. 20 times 8 is 160. Now, another information that could have helped me is look at the 4 sweatshirts. If 4 sweatshirts cost $80 and I double that, that would be 8 sweatshirts. What's 80 times 2? 160. So that's another way you could have gotten that answer. If 5 sweatshirts cost 100, double that, 10 sweatshirts cost 200. Or you could do 1 times 10 is 10, 20 times 10 is 200. 12, 1 times 12 is 12, so 20 times 12 is 240. Or if you look at the number 4, 4 times 3 is 12. 80 times 3 is 240. Now it's time to graph. So remember, sweatshirt sold is the x-axis, money collected is the y-axis. And if you notice, I filled in the numbers on the x-axis to help me plot. 4 sweatshirts, $80 means 4 comma 80. So I move 4 to the right, up 80. 5 comma 100 means 5 to the right, up 100. Plot that. 7 to the right, up 140. 8 to the right, up 160. 10 to the right, up 200, and then 12 to the right, up 240. Now we don't connect the points like this because you cannot sell partial sweatshirts. Like this would equal 1 at $20, but then this point here would mean half a sweatshirt for $10, but that's not the case. So you do not connect the points. Convert 15 feet into yards using a conversion factor. No, 1 yard equals 3 feet. And if you look at this, then I want to use conversion factor. So I'd write 15 feet first times, and I take the relationship and I write that over here. And I know since I'm trying to cancel this feet out, I would have to write this feet on the bottom, and then the yards will go on top. So then I write the relationship, 1 yard is 3 feet. Now we multiply, cancel out your feets. And then I notice that 15 in the top term and the 3 in the bottom term both could be divided by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. Then you multiply across, the answer is 5 yards. So 15 feet equals 5 yards. Darvin is baking. The recipe says that 8 cups of milk is needed for the dessert. How many quarts of milk is needed? Use a conversion factor. Know that 1 quart equals 4 cups. So I'm going to write 8 cups over 1 times, and I'm going to take the relationship and put it over here. Now I know that I'm trying to get rid of cups and turn it into quarts. So I'm going to put cups on the bottom and quarts on top, and then fill in the relationship on the right. 1 quart is 4 cups. I cancel my cups out here. These two get canceled out. And then I notice 8 and 4 could both be divided by 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Then you multiply across, and the answer is 2 quarts. Number 7. What is the limit in kilograms? Use a proportion or a conversion factor. No, 1 pound is about 0.454 kilograms. Here we're converting customary system in measurement into a metric measurement. Since they're different measurement systems, they're not going to equal each other as when you convert within systems. Like 1 foot equals 12 yards. 1 yard equals 3 feet, like that. So we're trying to change the 50 pounds from the picture of the luggage. And we want to know, like at the airport, the max weight is 50 pounds. How many kilograms is that? So we'll write 50 pounds over 1. I use conversion factor times. And since pounds is on top here, I have to put pounds on the bottom and kilograms on top. And then I put the relationship over here. Now I know I could cancel out my pounds. And then I can't do anything else. So I just multiply across. Multiply 454 times 50, which I did down here. Threw the decimal back in and move that over. 1, 2, 3. The answer is 22.7 kilograms. So 50 pounds is about 22.7 kilograms. What are the dimensions of the football field in feet? So you need to know the relationship that 1 yard is 3 feet. So let's find the length of this football field first in feet. If right now it's 120 yards, I use conversion factor times. I put yards on the bottom, feet on top. 3 feet is 1 yard. Cancel my yards out. I can't do anything else, so I multiply it across. The length of this football field is 360 feet. Now to find the width, 48 yards. So I wrote 48 yards times, I put yards on the bottom, feet on top, and the relationship. 3 feet is 1 yard. Canceled out my yards and then multiplied across. The width of the football field is 144 feet, and the length is 360 feet. A chalk line is placed around the perimeter of the football field. What is the length of this line in feet? Use the answer you found on slide 6 to help you with this question. It's actually slide 8. So if you take a look at, I'll adjust that for the actual question, but the answer key will have this. So go to slide 8 to help you answer this question. So to find, if you're doing chalk line, that means it goes around the whole distance, and that means you're doing perimeter. Now there's a couple ways to find perimeter. Add length plus width plus length plus width, or double the length plus double the width. And another way you could do, more 6th grade, would be add your length and width and then double that. So the formula for perimeter, you could copy this down, 2 parentheses, length plus width. You could double your length. You could add your length and width and then double that. That's a faster way to find perimeter. But again, you could always double the length plus double the width, or add length plus width plus length plus width. They do want you to use feet, so I had to use 360 plus 144, the information we found on slide 8, 360 plus 144, which equals 504. And when I double that, it's 1,008 feet. So that's how much chalk line we would have to use for this football field. A boat travels at a constant speed After 20 minutes, the boat has traveled 4 miles. The boat travels a total of 10 miles to a bridge. Graph the relationship between the distance the boat travels and the time it takes. So if it's 20 minutes, after 20 minutes, it travels 4 miles. I found the unit rate. How many minutes per mile? And I found that the boat travels 5 minutes each mile. Now, I did have to graph this information, and I noticed that time, minutes, is the x value, and then distance, miles, is the y value. So I wrote the ordered pair here, 20, 4. Now, using the unit rate, I figured out how many in 10 miles. If it travels 5 minutes, it takes 5 minutes per mile. How many in 10 miles? 1 times 10 is 10. 5 times 10 is 50. So 50 minutes for 10 miles. So that means I would have to plot this information also. And if minutes is the x, it would be 50, 10. So then I'm going to plot first 20, 4. So I move 20 to the right, up 4. And then 50 to the right, up 10. And since I could have partial time, partial miles, I did connect the points, drew an arrow at the end, and that's my graph. Feel free to always go back and try any of these problems again.